Hello, this is the fourth lecture of the Building Technology 1 series. I will be discussing about another interesting building material called concrete. This is considered as one of the most used building materials as we speak. Before discussing the material concrete, let us have a little history class first on how it was discovered and used extensively up until now, despite of new building alternative materials. Concrete was discovered by the Roman Empire. There is also an interesting myth that they discovered it by accident. The information and history about this material was written in Book 2 of the 10 Books on Architecture by Marcus Polio Vitruvius. He's an engineer, an architect, or also known as the master builder, and also a military tactician. The 10 Books on Architecture is one of the surviving treatises of construction that is used by the Roman Empire. The books were written as a gift to Emperor Octavian and serve as a manual on how to build an empire. Vitruvius is pretty much a very smart person considering he was an engineer, architect, and a master builder, and also a military tactician. It's amazing. After Vitruvius, there are also scientists that explored these ideas, one of which a world-renowned architect and artist and scientist during the Renaissance period named Leonardo da Vinci. One of his famous works is the Vitruvian Man, inspired by the concept of anthropometrics. Going back to concrete, the story began near Mount Vesuvius, the famous mountain and a very active volcano in Italy. The magma from the mountain hits the earth surrounding the volcano, causes the earth or the surrounding earth rocks to dry out. This substance can be crushed into powder form and then it can be turned into its original state by just adding water and then drying it. From that simple discovery, concrete was then developed by the Romans, turning it into their material of choice. However, the use of reinforcement was not still in use way back then. This caused building massive thick walls to build high structures. This method of construction allowed Romans in building magnificent structures that is still standing up to this day. The Roman Empire was already gone, yet their structures made of concrete are still standing. This includes the aqueducts, featuring the application of arches, the Forum, the Pantheon, which has the greatest unreinforced dome, by the way, and the massive Colosseum that became a symbol of the one of the greatest empires ever existed. So, what's concrete? Ano nga bang concrete? Simply, tinatawag lang ba siyang semento? Or sobrang common ng concrete everywhere we look around. Marami tayong makikitang applications and structures na made of concrete. Uh, Concrete is either plain or reinforced by definition. Plain concrete is an artificial stone as a result of mixing cement, fine aggregates, coarse aggregates, and water. Uh, it's a ito yung ingredients ng concrete. Basically, it's cement, fine aggregates or sand, coarse aggregates or gravel. Later, we will differentiate the difference between the two aggregates and water as causes a chemical reaction to the cement, allowing it to from in powder form going to or turning it into a solid. And reinforced concrete, on the other hand, is a concrete with with reinforcement. properly embedded in such a manner that two materials act together in resisting forces. Uh, Reinforced concrete is a combination of two materials. They have different properties, yet they act together uh, to add more stability. And for the third column, the basic ingredients of concrete, cement plus coarse aggregate, then fine aggregates plus water. And for the reinforced concrete, same ingredients or same materials, ang difference lang ay may reinforcement. An example of a reinforced concrete wall and a slab on grade. As you can see, you need to put formworks since concrete is on its liquid state and through hydration it turns into solid. You need to provide formworks as to mold the shape of what if you're doing a wall, then you need to provide formworks that is upright. So what are the components of cement? Since cement is uh, product of the earth, uh, the materials can also be found in other earthen materials. First is lime, 1.6 to 65%. As you can observe, lime is the predominant material in concrete. And next is silica, 18 to 25. By the way, silica is also used for making glass, process of glazing. Next is alumina, 3.8%. Iron oxide, 2.25%. Magnesium, 2 to 5%. Sulfur trioxide, 1 to 5%. This is not exact. As you can see, there is a range for the composition of cement. Are all cements are the same? The answer is no. There are many kinds of cement that you can use depending on your special requirements, special needs. The cement types are ordinary or Portland cement for general use. This is readily available in your local hardwares. Next is the rapid hardening Portland cement. This is preferred when high early strength of concrete is desired. Uh, this is recommended for road construction and infrastructure. To avoid traffic congestion, you need to work really fast. Next is blast furnace or sulfate cement. This is used on concrete structures designed to resist chemical attack. This can also be used for coastal infrastructures. Low heat Portland cement. This is used for massive sections designed to reduce the heat of hydration. If you're building large columns or girders for bridges, the kind of cement can be recommended is the low heat Portland cement. So that the concrete can be workable. And for the next type of cement is Portland pozzolan cement. This has a longer period of curing, but it's a sustainable uh, building material or method of construction components because of the components are mostly industrial waste, slag from volcanic products that are for disposal. And lastly, high alumina cement. Has a similar composition compared with the ordinary Portland cement, but has a higher alumina oxide content by about 32% by its weight. It has a very high rate of strength development compared with the ordinary Portland cement, which means this is more uh, mas mahal. It can also resist chemical attacks by sulfate and weak acids including seawater. This can also be used in industrial application and coastal infrastructures. Next is aggregates. You mentioned earlier the fine and coarse aggregates. What's the difference between the two? There are two classification of aggregates. There are coarse and fine. The coarse aggregates include crushed stones, gravel, and natural gravel retained on a 5 millimeter sieve. A 5 millimeter sieve is I provided an illustration. It's like a filter. It says that if the aggregates was retained in a 5 sieve means it's a coarse aggregate. And then if it passes through, then it's a fine aggregate. There's an example of that's it, 5 sieve. This device is used to segregate coarse aggregates from fine aggregates. There are also criteria for choosing the right size of aggregates. Let us read first the 4 bullets and then we'll discuss the example. For the coarse aggregate, uh, the maximum nominal sizes varies from 40 to 10 in diameter. I recommend if you're using it for a small structural member, as y- I recommend to use yung mas maliit na size ng aggregate para hindi siya bumara sa mga bakal. Kasi kapag bumara yun sa bakal, hindi even yung distribution ng aggregates and yung iba concentrated sa isang part, yung iba naman wala sa sides. Kaya mas maganda kung yung maliit na lang na size. The choice of the aggregates depend on upon the dimensions of the concrete member. Just like I said and I was discussing earlier, the spacing the steel bars or reinforcement or as specified. Third, the good practice demand that the maximum size of the course aggregate should not exceed 25%. Okay, let's take the illustration on the right as an example. Uh, it says here that the member is 10 inches and if we multiply it by 0.25, then the maximum aggregate size of aggregate should be 2.5 inches. The coarse aggregate should be small enough for the concrete to flow smoothly around the reinforcement. Yan. Dapat workable siya. Hindi siya yung nahihirapan pa kayo kapag nagbuhos. Hindi siya workable. Mahirap. Makakos ng delay. Baka tumigas yung concrete, di nyo pa naaayos yung pagbubuhos. Ay, yung pagbubuhos ng concrete. For the visual method, that I learned from masons or yung mga mason sa construction, this is the visual method choosing on the best aggregate. The left photo shows river stones that are round and has less addition with sand and cement. Since smooth nga siya, pwedeng mag-slip yung concrete and sand, ay yung cement and sand mixtures. Whereas in the right photo, showing an example of crushed stones that are ideal for coarse aggregate application. They are sharp and edgy appearance, provide more adhesion with sand and cement, producing better concrete. And then came the first industrial revolution. Uh, The first industrial revolution began in Britain. The mass production of steel began, and the use of steel was widespread from transportation, communication, and construction, to say the least. For you to imagine the industrial revolutions like this, mass production of products. And then 1855, there was a French civil engineer that used reinforcement to concrete and then discovered reinforced concrete. The amazing thing about concrete was it was discovered in Rome and was shared to different places and then developed into something that performs better in France by infusing metal reinforcement to concrete, making it more economical by using less concrete. Therefore, reinforced concrete became accessible to the public. Let's discuss reinforcement. Kung nakita na kayo ng ganito, ito yung reinforcement na nilalagay sa mga structural members. Without reinforcement, concrete would have to be thick and massive to function properly, just like the Romans did. It's like the illustration earlier. Romans built massive thick walls in order for them to build higher. By infusing steel, uh, you need you need to use less concrete, and then you can build higher. Fortunately, steel and concrete are chemically compatible and have a similar rate of dimensional change due to temperature. Ibig sabihin, kung nag-expand yung concrete at steel, although hindi sila magkapareho ng thermal expansion, but hindi nakaka-cause ng disruption sa composition nila once na nangyayari yung thermal expansion. Because kapag mataas yung temperature, material tend to expand. And then if the temperature is lower, it tends to contract. Here are the principles of mixing concrete. The following principles of concrete is to produce the optimum concrete that is workable. It should be also high in strength, durable, and economical. One of the most important thing that we need to consider when mixing concrete is the water cement ratio. Siyempre, dapat kapag may amount tayo ng cement, ganito yung mixture, dapat hindi yung sobrang dami ng tubig. Kasi kapag sobrang dami ng tubig, hindi siya magpe-perform ng maayos. It causes, para hindi siya para magamit pa siya, kapag tinatawag yun na lugaw sa site, vernacular term yun, lugaw. Kapag maraming tubig yung semento, bale para magamit pa siya ulit, ang gagawin, lalagyan ng bagong semento or isa pang bag para hindi siya lugaw, para mag-perform siya ng maayos. Less water can make the concrete less workable. And if you put too much water, it can lead to reducing the strength of the concrete. Or worse, di mo na siya magamit. Workability is the ability of fresh concrete to fill all the voids between the steel bars forms without necessarily exerting too much effort in tamping and consolidation. We'll be discussing tamping and consolidation in the next lectures. Next is the ACI requirements for concrete. By the way, ACI stands for American Concrete Institute. Uh, it is an to institution in regulating the use of concrete. Can be improved, run through researches to improve the performance. Here are their requirements for concrete. Fresh concrete shall be workable, meaning that fresh concrete could be freely flow around the reinforcement to fill all the voids. The hardened concrete shall be strong enough to carry the design load. Dapat tama yung design ng structural engineer. Kasi useless yung sobrang high performance concrete, maganda yung reinforcement. If yung undersized pala yung mga columns, dapat maganda yung material and then tama yung design. Hardened concrete should withstand the conditions to which it is expected to form. And lastly, concrete should be economically produced. Dapat hindi siya energy intensive or hindi siya sobrang massive na hindi na siya sustainable, sobrang over-design. And what's the sequence of mixing concrete? There are plenty of methods, but I will discuss the most basic ones. There's a uh, there's two, the manual method and the bagger mixer method. The manual method is you can do this by using a trowel. You can use a shovel. Let's discuss the manual method first. First, you need a mixing board and then you put sand on it. And after apply, putting sand, then cement, and you have to mix it 2 times. And if it mixed already, then you will put gravel and then water. What happened if you put gravel water first? It will tend to harden the cement immediately and it will cook. An erosion will occur. Bale, sand muna, then cement, tapos haluin, then graba, then water, then mix ulit. For the bagger mixer method, you need to, syempre, turn on yung mixer. Then kapag umaandar na, maglalagay ng water para may nakalagay na ng water doon sa mixer. Pero onti pa lang, hindi pa marami. Tapos next gravel, and then sand, and then cement, and check the level of water, and then if kulang, dagdagan. If tama na, wag nang lagyan. Paunti-unti lang yung paglalagay ng tubig. After mixing the concrete, let us proceed with placing and curing it. Uh, Concrete cured by hydration as a binding chemical combination of concrete and cement and water. Bale, aggregates, cement, and then tubig, tas magre-react yung cement, tapos yung water mag-evaporate, the water will evaporate and then leaving the concrete mix and ang natira na lang yung cement, fine aggregates, and yung coarse aggregate. Yun yung process ng hydration. Hindi lang siya overnight, hindi lang din siya 15 days, 28 days ang curing ng concrete. Surfaces can be kept moist by spraying them with water. Babasain mo siya for 28 days para even yung pag-dry ng concrete or covering them with moisture-resistant sheets. Ginagamit yung covering ng resistant sheets kapag nagbubuhos kayo ng slab. Slab kasi malaki. Tapos, natutuyo siya agad kasi palagi siyang exposed sa araw. Yan. Binabasa and then kina-cover siya. Tapos uulitin siya for the next few days or depende kung dry na. Pero sa mga unang araw ng curing, talagang mabilis ma-dry yung concrete. Yung sabi nga nila sa unang araw ng pagbubuhos na ay sa unang araw ng or sa mga few days after ng pagbuhos, yung concrete ay nauuhaw kasi ina-absorb niya talaga. Yun, for the curing time, it's 28 days. Kapag 28 days na, it is expected that concrete is fully cured. An example of spraying, yan, pagkabaklas ng forma, pagkatapos magbuhos, palaging ginagawa yan, curing of concrete. And then for, yan, covering. And for the admixtures, what are admixtures? These are uh, admixtures to alter the properties of the concrete. It can it can be used as allowing it to set immediately or to extend the life of the. Here are examples. Here are accelerator, retardant, air entraining, corrosion inhibitors, and fibrous admixtures. This is usually in liquid form or in powdered form. For the accelerator, it has the ability to promote set faster setting time. And then for the retardant, kasi yung kabaliktaran naman, it can hasten the curing. And for the air entraining, it increases workability of wet concrete, aid in reducing freeze thaw damage, and can be produced in lightweight thermal insulated concrete. Sorry sa definitions kasi may pang snow. Since nakuha ko lang din siya sa libro na Western, since ayun, nakuha. Pero ang air in training is para hindi siya masyadong uh, maging flowable yung concrete. Kunwari, kulang ng tubig, then gagawin ka ng air in training. Tapos, mag-improve yung workability ng wet concrete mo. And for the corrosion inhibitors, it reduces corrosion of the reinforcing steel. Di pa ako nakita ng ganito pero interesting siya. For the fibrous mixtures, short glass or steel or propylene fibers that acts as reinforcement. These are uh, parang plastic, propylene fibers. Sinasama siya sa pagbuhos ng concrete, improving the adhesion. Next is the silica fume. Produces extremely high strength concrete, sorry, with very low permeability. And for the super plasticizers, high range of water reducing admixtures. It also improves the workability of concrete. A famous brand for super plasticizers is Sika, water reducing admixtures to allow more workability by requiring less water. For fly ash, similar to silica fume and the blast furnace lag also. By the way, those are uh, industrial waste that are for disposal. And for pozzolans, it can improve workability, reduce internal temperature while curing, and reduce reactivity caused by sulfates. And also for the coloring agents to alter the appearance of the concrete for finishing purposes. That's it. And concrete as finishing. Uh, Since concrete is a beautiful material, some architects or designers intend to showing concrete as it is. It can be used as cast without painting it. And for the next example, blasted can be used by sandblasting. Smooth the surface while exposing successive levels of cement, sand, and aggregate. Basically, sandblasting is uh, putting texture on the concrete. For the chemically retarded, uh, same purpose, like to expose the aggregates. And for the mechanically fractured, tooling or hammering, jackhammering, and scaling produce varied aggregate exposing effects. Next, polish, uh, making the concrete glossy. This is very common in warehouses, in industrial buildings, even schools. They use polished concrete and for seal. It's the same with polished concrete, but it has an acrylic or epoxy layer for for protection. An example for cast, as you can see, it's very beautiful. And the left illustration is sandblasted, and the right is chemically retarded. And for the mechanically fractured, the left side, and for polished and sealed. So you can see polished and sealed is almost the same, but sealed has a epoxy coating. And for colors, coloring concrete, there are also methods to alter the color of concrete, two of which are integral coloring applied in wet concrete, making it homogeneous, and dry shake color hardeners. Apply on top of concrete after the curing time. I provided an example for integral coloring. And then for the dry shake, it's in powdered form. To avoid overwhelming you for too much information, I will be discussing concrete in two separate videos to make it more manageable. Let me share my resources for making this lecture. I want to have a copy of this. It's very useful. I still use it, and I was introduced by my classmates in college by these books. This will help you very well in understanding building materials better. I have a copy of this when I was in college, and I still use it up until now. Concrete is a very convenient building material. Combining it with steel, making it much better. Despite of its advantages and serving humanity to flourish, the overuse of concrete causes high carbon emissions, contributing to global warming. So, yun, kailangan maging economical yung paggagamit ng concrete, hindi yung concrete mo na lang yan, concrete mo na lang to. Dapat uh, i-lessen din natin yung dependence natin sa concrete kasi meron pa namang mga magagandang material din na maraming potential na pwede nating magamit as architects. So, ayan, thank you for listening.